We've seen a little bit of algebra, we've seen a little bit of calculus. Now let's move on to yet another big section, which is coordinate geometry. We're going to start our discussion in coordinate geometry by looking at the first chapter, which is straight lines and pairs of straight lines. It's a very interesting chapter, and in this video I am going to do an analysis of the chapter from the JEE examination point of view, then look at the concepts which are important from this chapter for the examination before going on to the all-important questions. We will solve a few interesting questions from this chapter and make sure that you are aware of how important this chapter is from the JEE examination point of view. So quickly, let's look at what happened in the past few years. Now, straight lines is not a chapter which fetches questions every year in the JEE Advanced examination. This is not the case with the main, because every year at least 1 or 2 questions come from from straight lines in the main examination. In fact, starting 2013 until the recently concluded 2019 main examination, every year 1 question has come. In fact, in the year 2014, there were 2 questions which came from straight lines in the main examination. In the main examination, the concepts which are covered from straight lines in the examination are not too many. Normally, questions which come are based on intersection of straight lines or probably, 3 straight lines form a triangle. Some interesting concepts from there are tested. 2014, 2016, 2018, all these 3 years, we had questions in the main examination from intersection of straight lines. Of course, in 2013, 15, 17 and 19, the questions which came mostly tested your knowledge on slopes of straight lines and different forms of equations of straight lines. Now, that is not the case in the advanced examination. Not every year questions come directly from straight line in the advanced examination. In fact, in the past 4 years, no question has come from straight lines. 2014, there was an integer type of question. 2013, there was a single correct answer kind of question in the advanced examination. In fact, in 2013, the question was a very simple one, which was based on intersection of straight lines. And in 2014, also the question had to do a little bit with slopes and intersection of lines. But does that make straight line a less important chapter? Not at all. Now, this is the first chapter of coordinate geometry. So this means that this is a chapter where you understand how to represent geometrical figures using algebra. That knowledge is going to play a big role as you look at chapters of greater importance in the exam, such as parabolas, circles, the other conic sections, hyperbolas, ellipses, and you move on to 3-dimensional geometry. So the knowledge that you will pick up from this chapter is going to play a big role in how well you perform in this giant section of coordinate geometry. Let's quickly go through the important concepts in straight lines, and then we'll solve questions. That's going to be fun. So when we look at straight lines, we begin by teaching you the concept of slopes. Slope is a very interesting concept that's going to come a long way, all the way till you finish your study on coordinate geometry. So you have to understand the easy concept of slope and how it is related to the tan of the angle of inclination. Then we look at how to compute the angle between 2 lines given the slopes of these 2 lines, before moving on to the all interesting and important equations of straight line. Now, you're looking at the equation of a curve for the first time. You've never before represented a geometrical figure in terms of an algebraic equation. So that makes equations of straight lines very interesting. And we look at the different forms of equation of a straight line. We look at the very interesting slope-intercept form. We look at the point-slope form. We look at the 2-point form, the intercept form, and also we look at the standard form of a straight line, which many mathematicians don't like, but we from the JEE examination point of view love this standard form of the equation of a straight line. Then we also look at the parametric form of straight line. The reason why you look at parametric form of a straight line is sometimes some questions can be solved using a parametric form of a straight line, but more importantly, straight lines find a lot of applications in other chapters, because in every chapter you will inevitably look at tangents, which are nothing but straight lines. So knowing the parametric form of a straight line is sometimes useful, because you know that in other chapters such as circles and parabolas, the parametric form of those curves are very, very important. So it's also important to know the parametric form of a straight line. Then we look at the all-important intersection of lines. This concept is very crucial from the JEE Main examination point of view, because every year a question comes and inevitably you will have to find out the point of intersection of lines to solve that question. Also, a related concept to intersection of lines is concurrency of lines, and concurrency of lines is a concept which will sometimes find applications in the advanced examination, and we have two different conditions for the concurrency of lines. One is the determinant form and the other is the equation form, where you take three parameters, lambda 1, lambda 2, lambda 3, and we consider the equation L1, L2, L3 as the left hand side of the standard form of a straight line, multiplying them with lambda 1, lambda 2, lambda 3, equating it to 0, we get the condition for concurrency. This is an advanced level concept, not a JEE Main level concept. One very interesting and important concept in straight lines is distance of a point from a straight line. This is not something that is tested often in the chapter on straight lines, but this concept is quite inevitable in the chapter on circles, because we always know that a tangent to a circle is at a perpendicular distance from the center of the circle, and that perpendicular distance is the radius. So this concept is going to be used multiple times to solve questions involving circles and their tangents. So you better know what is the distance of a point from a straight line. Now when we talk about distance, it's the perpendicular distance of a point from a straight line, or the shortest distance. Yet another interesting kind of question which comes from straight lines, or more importantly from other chapters of coordinate geometry, is questions involving images. Now a straight line acts as a mirror. You have to find the image of a point, you have to find the image of curves about a straight line, and this concept is carried forward to three-dimensional geometry also. So image of a straight line and the entire procedure of how to find out the image of any curve about another curve or a straight line most often is an interesting thing, and it's worth understanding because questions appear frequently from this concept in chapters such as ellipses, hyperbolas, parabolas, and also three-dimensional geometry. So it's worthwhile understanding how do you find out the image of a point about a line in this chapter itself. Then we look at family of straight lines. When we talk about family of straight lines, we start talking about the pair of straight lines, and if you have two equations of a straight line, how do you get the equation for the pair of a straight line? And then we move on to the general second degree equation and find out the condition when a general second degree equation represents a pair of straight lines. Now a pair of straight lines is also important in the main examination, but it's really important in the advanced examination. In the main examination, sometimes in the past, I've seen before 2013, a pair of straight lines used to be tested much more than it is being tested after 2013. But it's of course not a chapter, not a section that you can avoid completely. You should go through this section if you're preparing for the JEE Main examination. Of course, if you're preparing for the advanced examination, you have no choice but to master this section, because inevitably when the question comes from straight lines, there will be some mention of pair of straight lines somewhere in that question. Not happened in the past many years, but why take a chance, isn't it? Then we look at the different forms of a pair of straight lines and some interesting cases when both the pairs of straight lines pass through the origin. We look at what is the slope of both the lines, what is the angle between these two lines, what happens when these two pair of straight lines are bisected, their angles are bisected by another pair of straight lines, how do you represent these? And there are so many interesting topics in pairs of straight lines which are worth going through. I am going to actually solve a few questions from pair of straight lines to illustrate the different things that you can do with pairs of straight lines. That will be there at the end of this video. So these are overall the interesting concepts from straight lines and pairs of straight lines which are important from the examination point of view. But of course, knowing these concepts are not enough. It's important that you solve questions. So that is why I'm going to now take you through some questions. We will solve a few questions and then you can solve many more questions and prepare very well for the examination. Let's have a look at some very interesting questions from straight lines and pair of straight lines. In this first question, we are going to play with the concepts of slope and equation of straight line. So in this question, we have been told that a line which is joining the points A and B, these are the coordinates of points A and B, 3, 1 and 2, 2, is rotated 15 degrees anti-clockwise about the point A, which means even after rotation, the line is going to pass through the point A. Now the equation of the line after rotation is of the form y is equal to mx plus c. The objective is to find out the value of the expression c plus 1 by m. So let's try and solve this very simple question. First and foremost, let's try and find out what is the slope of the line joining A and B. Pretty straightforward. So the slope is going to be nothing but the difference in the y coordinates divided by the difference in the x coordinate. So that's going to be 1 minus 2 divided by 3 minus 2. That's going to give me -1. What is the inclination of this line? You know that the slope is nothing but tan theta, and if tan theta is -1, this means that the inclination of the line is going to be equal to 135 degrees, right? Tan theta is -1 in the second quadrant, so this means that the value of the angle that the line makes with the positive x-axis is going to be 135 degrees. So what is the inclination of the line after rotation? We are rotating it 15 degrees anti-clockwise, so then the angle is going to be 135 plus 15, that's going to be 150 degrees. So now we have the angle that the line makes after rotation with the positive x-axis. So we can definitely find out what is the value of the slope. The value of the slope is going to be tan of 150 degrees. Tan 150 is nothing but tan of 180 minus 30. So that's going to be minus tan 30. So this is going to be equal to -1 over root 3. So the equation of the line is going to be y is equal to -1 over root 3x plus the constant. Now we have to find out what is the value of the constant. We know that this line will pass through the point A even after rotation. So this means that I can substitute for xy equal to 3, 1. So y equal to 1, x is equal to 3. So then I will get 1 equal to -3 over root 3 plus c. Of course, this is very, very simple to solve from here. So I get the value of the constant to be equal to root 3 plus 1. So I know the value of m, I know the value of c. I need to find out what is c plus 1 by m. So c is root 3 plus 1. M is -1 over root 3. So 1 by m is going to be -root 3. So these root 3's will cancel out and I will be left with 1. So very simple question. I have elaborated it a little too much, but this is a simple question to understand the concepts of slope and equation of a straight line. So in this question, we've been given a point. Now the coordinates of this point is a, a square. And we've been told that this point lies inside the triangle formed by the three straight lines 2x plus 3y minus 1 equal to 0, x plus 2y minus 1 equal to 0, and -8x plus 8y plus 2 equal to 0. The objective is to find out what are the possible values that a can take such that the point a, a square lies in the triangle formed by the three straight lines. So I'm going to do this question first by visualizing and then applying the algebra. First, let's try and visualize. So for that, I'm going to draw all the three straight lines. It's pretty simple to draw all the three straight lines. You just have to find out the intercept of the three straight lines and then it's as good as done. So these are the intercepts of the first straight line. These are the intercepts of the second straight line. These are the intercepts of the third straight line, and joining all these things, I get the three straight lines and the triangle inside which that point has to lie. So now, how do you find out the condition for any point to lie inside this triangle? Now, we know that if a point lies on a straight line, then it satisfies the equation of the straight line. Now, right or left, it satisfies the inequality that the straight line represents. So these two regions are going to be inequalities of the straight line. So we will get one region which is going to be greater than 0, other region which is going to be less than 0. So we have to find out the condition, the inequality that has to be satisfied for a point to lie inside that triangle. So first, let us consider the straight line 2x plus 3y minus 1 equal to 0. So I am going to consider the origin and find out in which region does the origin lie. And then if the point a, a square also lies in the same side as the origin, then it satisfies the same inequality, otherwise the opposite inequality. With 2x plus 3y minus 1 equal to 0, you will see that the origin and a, a square are on opposite sides. So the inequality satisfied by the origin will be the opposite of the one satisfied by a, a square. So let's look at what is the inequality satisfied by the origin. I'm going to put in the value of 0, 0 in the expression and I get -1. So this means that the origin is actually 2x plus 3y minus 1 less than 0 region. Correct? So a comma a square is in the opposite region. So a comma a square satisfies the condition 2x plus 3y minus 1 greater than 0. You understand the drill? This is how we are going to find out the other two inequalities. Plug in the value of 0 comma 0 here and you get negative 1, which means that the origin lies in the region x plus 2y minus 1 less than 0. Is the point a comma a square in the same region as the origin? Of course it is. So the second inequality is x plus 2y minus 1 is less than 0. What is the third inequality? Well, the third inequality is going to be also founded in the same way. Plugging in 0 comma 0 in the third equation, I get 2 and 2 is greater than 0. This means that the third line is a comma a square in the same side as the origin for the third line? Of course it is. So this means that minus 8x plus 8y plus 2 is greater than 0 is the region in which a comma a square lies. So now plug in the value of a comma a square for x comma y in all the three inequalities, and here are the three inequalities which you have to solve simultaneously. 2a plus 3a square minus 1 is greater than 0, a plus 2a square minus 1 is less than 0, and negative 8a plus 8a square plus 2 is greater than 0. To solve them simultaneously, you see that all the three are quadratic inequalities, so you have to solve all the three quadratic inequalities. So if you solve the first one, you get the factors 3a minus 1 multiplied by a plus 1, and this has to be greater than 0. We're going to make use of the very famous wavy curve method. So the critical points are going to be a is equal to 1/3 and a equal to negative 1. So divide your entire values of a into three intervals separated by negative 1 and 1/3. Find out the value of this expression in all the three intervals, and you will immediately find out that for this expression to be satisfied, you have the value of a to be less than negative 1 or a to be greater than 1/3. So this one inequality is going to give you these two regions as possible values of a. Now we have to intersect these regions with the other two inequalities, and finally the intersection of all the three inequalities is what is the correct answer. So the next inequality, that's again quadratic. Upon simplifying, you get 2a minus 1 multiplied by a plus 1 is less than 0. And now my wavy curve method, critical points are going to be half and negative 1. And then again, we look at the sign of the inequality in all the three regions. And what happens? You will find out for that this inequality to be true, a has to lie between negative 1 and half. So a has to lie between negative 1 and half. See, now we've got an intersection region. So this intersection region is the only possible region for these two inequalities to be simultaneously satisfied. Let's look at the third inequality and we'll get probably a smaller region. So if you solve the third inequality, it's a perfect square. So you get 2a minus 1, the whole square greater than 0. Now this is always true except for the case when the left hand side equal to 0. The left hand side will be equal to 0 when a equal to half. So a should not be equal to half. For all the other values, this inequality is always satisfied. So this means that my final answer is going to be that region of intersection which is a lying between 1/3 and a half. So the correct answer to this question is a lies between 1/3 and a half. So in this question, we've been told that the line y equal to mx bisects the pair of straight lines, which is described by this equation here: x squared times sine square theta plus tan square theta plus 2xy cos theta plus y square secant square theta equal to 0. Now they've told us that when theta equal to pi by 3 or 60 degrees, then the value of m is this expression a plus or minus under root b divided by 4. The objective of this question is to find the value of the expression b minus 10a. It's a very fancy way of asking you to find out the values of a or a and b, or in other words, it's a very fancy way of asking you to compute the value of m. So this is a very standard question because we know the expression for the bisectors of a pair of straight lines. So we have the combined equation for the bisectors of a pair of straight lines. So if we have an equation of a pair of straight lines as ax square plus 2hxy plus by square equal to 0, then the equation of the pair of straight lines which bisects the angle between these two lines is nothing but x square minus y square divided by a minus b, which is equal to xy divided by h. So I'm just going to make use of this formula. In our case, the a is going to be this whole expression here, which is sine square theta plus tan square theta. B is going to be secant square theta, and my h is going to be just cos theta. Right? So I just plug in these values and I get the expression, in fact the equation for the pair of straight lines which are the bisectors of the given pair of straight lines. So it's going to be nothing but x square minus y square divided by sine square plus tan square minus secant square theta equal to xy divided by cos theta. Now I'm going to do a little bit of mathematical manipulation. This is where the concepts of straight lines end, and now it's all mathematical manipulation. So I have a tan square theta minus secant square theta. I know what is secant square minus tan square, that's equal to 1. So this is going to be equal to negative 1. So then I'm left with sine square minus 1 in the denominator. I know what is 1 minus sine square, that is cos square. So sine square minus 1 is minus cos square. So the denominator is nothing but minus cos square theta. So I have x square minus y square divided by minus cos square theta is equal to xy divided by cos theta. The value of theta is actually not equal to 90 degrees. So that means that the denominator will never be equal to 0. So I can cancel out one of the cos's from the denominator, and eventually I am left with the expression x square minus y square divided by minus cos theta equal to xy. What is the value of theta? The value of theta that we are interested in is equal to pi by 3. So cos pi by 3 is nothing but is nothing but half. So what happens is the value here is half. I take it to the right hand side and I get x square minus y square equal to negative xy divided by 2. So this is the joint expression of the equation for the pair of straight lines which are the bisectors of the two given straight lines. So now our objective is to find out what is the value of m if y equal to mx is one of the bisectors. What you're going to do is you're just going to substitute the value of y with mx in that expression and simplify. You get x square minus m square x square equal to negative x times mx, which is going to be negative mx square divided by 2. I'm going to cancel out all the x squares from here because x equal to 0 is not an interesting solution for me, because if x equal to 0, y is also equal to 0, so we're not interested in that. So I am cancelling out all the x square terms, so I will be left with 1 minus m square equal to negative m over 2. So if I simplify that, I get 2 minus 2m square is negative m. It's a quadratic equation. If you solve this quadratic equation, in fact you will get 2m square minus m minus 2 equal to 0. Solve this quadratic equation using the quadratic formula and you will get the value of m to be equal to 1 plus or minus under root 17 divided by 4. What has been told in the question? They've told that the value of m is a plus or minus under root b over 4. So that sort of matches with this m that has been given. So immediately I can say that my a equal to 1 and b equal to 17. Now remember the fancy expression which we had to find the value of, that was b minus 10 times a, 17 minus 10. So the correct answer to this integer kind of question is number 7. Now this question appears a little convoluted. The first thing that I am going to do is I am going to try and understand what has been told in this question. So from my understanding, I understand that there is a straight line which is 2x plus y plus 10 equal to 0. So this straight line, there is a portion of this straight line between the coordinate axis. Okay, so this portion of the straight line between the coordinate axis is divided by two other points in the ratio 1:2:2. Now, what are these 2 points? These 2 points are actually the points of intersection of a pair of straight lines with this given straight line. Okay, so 2x plus y plus 10 equal to 0 is a straight line that is intersected by a pair of straight lines at 2 points such that the portion of this line between the coordinate axis is divided in 1:2:2 ratio. I hope you understand this from what is given in the question. Now, what is the other thing they've told us about the pair of straight lines? The other thing that has been told about the pair of straight lines is that they pass through a common point -6, -8. Now, the objective is to find out the acute angle between the pair of straight lines. So this question is in fact not as convoluted as it appears. This is a pretty simple question, and if you break it down and do it in a very systematic way, it's pretty simple. So the first thing I'm going to do is I'm going to find out the two intercepts of the straight line, because if I find out the intercepts, then I can find out the portion of the straight line between the coordinate axis. So I'm going to rewrite the equation of the straight line in the intercept form. Okay, so what I do is I take the -10 onto the right hand side. So after taking -10 to the right hand side, I divide throughout by -10. So I get the intercept form of the line, which is x divided by -5 plus y divided by -10 is 1. So I know what are the two intercepts now. The x intercept is -5, 0, and the y intercept is 0, -10. So these are my coordinates of the x intercept and the y intercept. So I know the portion of the straight line. So the portion of the straight line is a part which lies between this point -5, 0 and this point 0, -10. Another information that I'm going to extract from the straight line is the slope of the straight line. The slope of the straight line is nothing but negative of the coefficient of x divided by the coefficient of y, which is going to be -2 divided by 1. So the slope of this line is going to be -2. So now let's visualize this. So I have this point here, which is -5, 0. I have the other point, which is 0, -10, and I have a straight line passing through this. So let's try and find out what is the length of this line. What is the length of this line? The length of this line is going to be nothing but under root of -5 square, which is 25, plus under root of 10 square, which is 100. So this is going to be under root 125, which is nothing but 5√5 units. So this straight line between the coordinate axis is of length 5√5 units. Now this is divided into 3 parts. 1:2:2, which means that a net of 5 parts, isn't it? If there were 5 points equally dividing it, then there would have been 5 parts. So 1:2:2, that clearly means that the length of each of these is going to be 1x, 2x and 2x. So 5x is divided into 1x, 2x and 2x. So very easily I can find out what is the value of x. X is going to be √5. So if P and Q are these 2 points which are dividing this portion of the straight line between the coordinate axis into 3 different parts, then the length of the section between the x-intercept and P is going to be √5. The next section is going to be equal to 2√5, and the final section is also going to be equal to 2√5 units. Now we have to find out the coordinates of P and Q, and using the fact that the slope of the line is -2, I'm going to very easily find out what are the coordinates of these points. Because what is the meaning of slope equal to -2? Slope equal to -2 means when I move vertically by 2 units down, I have to move horizontally by 1 unit to the right. Correct? So now what is happening in the first portion? The first portion is divided into 1 unit, into x units. So I have to move down 2 and then I will move right 1. So the coordinate of P is going to be very easily -4, -2, right? Because from -5 it increased to -4, from 0 it decreased to -2. Now the next section is 2 units, it's 2x units or 2√5 units. So now this section I have to move down 2 times. So I move down 2 and then I move down 2 again, and to the right I move 2 times. So now the point has coordinates -2, -6. Pretty simple, isn't it? I have found out what are the coordinates of P and Q. I also know the fixed point through which the pair of straight lines are going to move. The pair of straight lines are going to pass through -6, -8, which means that I can easily find out the slope of AP and AQ. If I know the slopes of AP and AQ, can I not find out the angle between them? Pretty easily I can find out what is the angle between them. So that is what is my interest in this question. So what is the slope of AP? Well, the slope of AP is going to be -2 minus -8, which is going to be +8, divided by -4 minus -6, which is going to be +6, gives me a value of 6/2, which is nothing but 3. What is the slope of AQ? Similar way, I'll find out -6 plus 8 divided by -2 plus 6. Simplifying this, I get the value to be equal to half. So if theta is the angle between AP and AQ, then I can find out what is theta using the expression tan theta equal to 3 minus a half divided by 1 plus 3 by 2. I get 5 by 2 on the numerator. I get 5 by 2 in the denominator. That's equal to 1, which means that the acute angle between the pair of straight lines is 45 degrees. Very, very simple question. In fact, there were no concepts of pairs of straight lines involved in this question. It could have been solved with absolutely no knowledge of pair of straight lines. You just needed to know the concepts of section formula a little bit and to visualize the graph a little bit, and finally what is the angle between a line in using the concept of slopes of lines. Very interesting question, and I hope you had fun solving this question. The problem statement in this question is pretty short, but the solution, is it going to be as easy as the problem statement? Let's have a look at the question. So A and B are 2 points on the pair of straight lines 4x square minus 9y square equal to 0. The area of triangle OAB, where O is the origin, is equal to 5. Now the objective is to find out the locus of the midpoint of AB. A very interesting question, and we'll solve it in a very systematic way. So the pair of straight lines which is given to us is 4x square minus 9y square equal to 0. So very easily we can find out the two component lines. This is nothing but 2x plus 3y multiplied by 2x minus 3y equal to 0, which means that my two lines are 2x minus 3y equal to 0, or 2x equal to 3y, and 2x plus 3y equal to 0, which is 2x equal to negative 3y. So these are the two straight lines which form the pair of straight lines. I'm going to call the angle between them to be equal to theta. Okay, so now I'm going to mark a point A. So let's say point A is on 2x equal to 3y and point B is on 2x equal to negative 3y. Okay, so these are my two points A and B. Suppose the x coordinate of point A is h, then the y coordinate of that point is going to be very easily 2h divided by 3 because of the equation of the straight line. Similarly, if the x coordinate of point B is k, then the y coordinate is very simple, minus 2k divided by 3, correct? Now, what is the area of triangle OAB? Now, the area of triangle is going to be OA times the length of the altitude dropped from B onto OA, correct? Now, what is that length going to be equal to? That length of the altitude is going to be equal to OB times sine theta. If theta is an obtuse angle, then sine of pi minus theta, but sine of pi minus theta is also sine theta. So in every way, it is going to be OB times sine theta. So that area of the triangle is 1/2 OA times OB times sine theta. And we are going to consider the modulus value of this because, you know, in coordinate geometry, lengths can sometimes be negative because of the direction in which we compute them. But we always consider distance to be a positive unit. So we consider the modulus. So area of triangle OAB is a modulus of half into OA into OB into sine theta, and this is equal to 5 units. So now let's find out what is the distance of OA. Using the distance formula, we can find out OA, and OA will turn out to be nothing but root 13 by 3h. Similarly, OB will turn out to be root 13 by 3k. Now we need to find out the value of sine theta. What is sine theta? So the slope of the line 2x equal to 3y is nothing but 2 by 3, and the slope of 2x equal to negative 3y is nothing but minus 2 by 3. So I can easily find out tan theta, tan of the angle between these two lines. That's going to be 2 by 3 minus of minus 2 by 3 divided by 1 plus 2 by 3 into minus 2 by 3. So using this, it's going to be very easy. I have a 4 by 3 in the numerator, and I have a 1 minus 4 by 9 in the denominator, which is nothing but 5 by 9. So if I simplify this, I get 12 over 5. If tan theta is 12 over 5, it's our very favorite Pythagorean triplet, which is going to be 5, 12, 13 triplet. So sine theta is going to be 12 over 13. So now I know the value of OA, OB and sine theta. Plug it in and you will find out that you get a relation of hk equal to 15 over 2. In fact, modulus hk equal to 15 over 2, or hk equal to plus minus 15 over 2. So I have a relation between h and k now, and we're going to make use of this in order to find the locus of the midpoint of AB. So what is the midpoint of AB? Very simple. You have the coordinate, you use the midpoint formula. So it's going to be h plus k divided by 2, and the other one is 2h by 3 minus 2k by 3 divided by 2. So if you simplify this, you get hk plus 2 comma h minus k divided by 3. So if this point is any random point x comma y, because we are interested in finding the locus of AB. So if the point AB midpoint is x comma y, then my x is going to be h plus k divided by 2, or h plus k is going to be 2x, and h minus k is going to be 3y. So if I add these two equations, I get 2h to be equal to 2x plus 3y. If I subtract these two equations, I get 2k equal to 2x minus 3y. Why did I do that? Now I have an expression for h in terms of x and y, k in terms of x and y. If I multiply them, I get an expression of hk, and I know the value of hk, correct? So I get an expression in terms of x's and y's because hk can be evaluated. So multiply these two expressions, I get 4hk equal to 4x square minus 9y square. Very interesting, because 4x square minus 9y square is actually the equation of the pair of straight lines. So the equation of the midpoint somehow has this pair of straight lines also appearing in it. So 4x square minus 9y square equal to 4hk. I know what is hk. Hk is plus or minus 15 over 2, which means 4x square minus 9y square equal to plus or minus 30 is the locus of the midpoint of AB. What are A and B? Two random points on the pair of straight lines. So this is an interesting result. This has been presented in the form of a problem, but for those curious ones out there watching this video, this result is very interesting because the locus of the midpoint of two random points in the pair of straight line also has the expression of the equation of the pair of straight lines in it. Worth giving a little bit of thought. So I will now see you with another question, but if you all want, you can pause this video and think about this result for some time. So in this question, it has been stated that a pair of straight lines x square minus 2hxy plus y square equal to 0 make an angle theta with the straight line x plus y equal to 2. So this means that the pair of straight lines are making an equal angle with x plus y equal to 2. The objective of this question is to find the relation between theta and h. How do you go about this question? Let's consider the components of x square minus 2hxy plus y square equal to 0. So the components are going to be y equal to m1x and say y equal to m2x. So this is how I'm going to solve this question. I'm not going to use the formula for the bisector of the angle because that's going to make this question a little more convoluted. I'm going to use this formula, which is y equal to m1x and y equal to m2x being the component lines of the pair of straight lines, and then solve this question. So if y equal to m1x and y equal to m2x form the straight line x square minus 2hxy plus y square equal to 0, then if you multiply these two equations, you can actually find out a relation between m1, m2 and h. You will find out that m1 plus m2 equal to 2h and m1, m2 equal to 1. So that's a very interesting relation. We're going to keep that aside and play with it a little later. We will now move on and look at what is given to us. So both these lines make an angle theta with x plus y equal to 2. So if both the lines make the same angle theta with x plus y equal to 2, this means that these angles are going to be measured in two different directions, right? So one angle is going to be measured in the clockwise direction, the other one is going to be measured in the anti-clockwise direction. So you have to remember this. So if m1 is the slope of the first line, and what is the slope of x plus y equal to 2? Well, the slope of x plus y equal to 2 is minus 1. Negative coefficient of x divided by y, that's minus 1. Okay, so the slope of first line is m1, the slope of second line is minus 1. So you can find out the angle between this, which is theta. Tan theta is equal to m1 minus minus 1, which is m1 plus 1 divided by 1 plus m1 into minus 1, 1 minus m1. Okay, that theta is also equal to the angle between the second line y equal to m2x and x plus y equal to 2, correct? So using the formula for the slope, we will again get m2 minus minus 1, m2 plus 1 divided by 1 plus m2 into minus 1, which is 1 minus m2. That is also equal to tan theta, right? But there's a small catch here. both these are not equal to tan theta. One of these is equal to tan theta and the other one is equal to minus tan theta because we are measuring in the other direction. So this minus is very, very important. So m1 plus 1 divided by 1 minus m1, I'm going to call that tan theta. And m2 plus 1 divided by 1 minus m2, I'm going to call that minus tan theta. So that's a very important key bit here. So from this expression, I'm going to express m1 in terms of tan theta, m2 in terms of tan theta. Why am I doing that? Because I already have expressions for m1 plus m2 and m1, m2. So if I express m1 and m2 in terms of tan theta, I can play with the old result I have. So from the left hand side of the expression, I get m1 equal to tan theta minus 1 divided by tan theta plus 1. From the other side, I get m2 equal to tan theta plus 1 divided by tan theta minus 1. I'm not going to multiply these two. I'm going to add these two. You might as well multiply them. I'm going to add these two. So if I add these two, I get m1 plus m2 equal to, taking common denominators, tan theta minus 1 the whole square plus tan theta plus 1 the whole square divided by tan square theta minus 1. Now tan theta minus 1 the whole square is tan square theta plus 1, which is secant square theta minus 2 tan theta. So this first part is going to be secant square theta minus 2 tan theta, and similarly the right part is going to be secant square theta plus 2 tan theta. The denominator is going to be tan square theta minus 1 itself. I'm not going to simplify that. So the 2 tan thetas are going to cancel out and I have 2 secant square theta in the numerator and tan square theta minus 1 in the denominator. We're going to express everything in terms of sines and causes. And so what we get in the numerator is 2 by cos square theta, and in the denominator I will have sin square theta minus cos square theta divided by cos square theta. The cos square thetas cancel out. So what is sin square theta minus cos square theta? Sin square theta minus cos square theta is minus cos 2 theta. So I have 2 divided by minus cos 2 theta. m1 plus m2, remember, was equal to 2h. So 2h is equal to 2 divided by minus cos 2 theta, or in other words 2h is equal to negative 2 secant 2 theta. So now we have got a relation of h and theta. But look at the options. We don't have h equal to minus secant 2 theta in the options. So now we have to do a little bit of mathematical manipulation. That's what we are going to do. So what is so I'm not going to write this as minus secant 2 theta because in the expressions nowhere I have a secant appearing. So let's write it in a slightly different way itself. So I'm going to write minus 1 by h equal to cos 2 theta. Correct? So minus 1 by h is equal to cos 2 theta. So cos 2 theta is nothing but 2 cos square theta minus 1. Correct? So minus 1 by h is equal to 2 cos square theta minus 1. So cos theta, if I take the minus 1 on the other side, divide by 2 later on and take a square root, cos theta is going to be under root of h minus 1 by 2h. So if cos theta is under root of h minus 1 by 2h, again the options are not going to help us with this. So probably let's look at what are tan and cot, because the options have tan and cot also. So if cos theta is root of h minus 1 by 2h, this means that the adjacent side has h minus 1 into some m, and the opposite side is root 2h, again with an m. So now what is the value of tan theta? Tan theta, if you compute, will be equal to under root of h plus 1 divided by h minus 1. Now the option says cot theta is equal to under root of h minus 1 divided by h plus 1. So if tan is under root of h plus 1 divided by h minus 1, then cot has to be under root of h minus 1 divided by h plus 1. It was a very convoluted way of arriving at the solution. A very interesting question, mostly mathematical manipulation, less of straight lines. So this is the thing with straight lines. The questions that appear from straight lines tend to be generally lengthier questions. Because the concepts in this chapter are not so convoluted, the exam paper setters, they eventually make the questions long so that, they can salvage out for the fact that the question is actually a little simple. Straight lines is an interesting chapter, not so important from the JEE examination point of view because not every year questions appear from this chapter, but it's the fundamental chapter of coordinate geometry, and this is where you actually learn how to relate algebra to geometrical figures. So this chapter, understanding the concepts here, is going to play a big role in how well you understand circles and conic sections and all of three-dimensional geometry which is to follow. So make make sure that your understanding of straight lines and coordinate geometry is pretty strong so that you will have a lot of fun when you move on to conic sections and more advanced chapters. I'll see you soon with yet another interesting chapter. Till then, have fun preparing for the JEE Advanced examination, and I will see you very soon.
For more videos and live lectures on the JEE, click on the subscribe button now.